Hi, my name is James Cabe. I'm a global black belt for Microsoft. I am very specific to IT and IoT and OT cybersecurity. Today, we're here to talk to you about the differences between OT cybersecurity, which is operational technology, and IT, or information technology cybersecurity.
My name is Anthony Bartolo, and I'm a senior cloud advocate here at Microsoft, and I'm going to be playing the role of learner. I'm very intrigued by what we have to take into consideration when deploying a cybersecurity solution on an IoT architecture.
Excellent. So, Anthony, have you had any kind of experience with OT cybersecurity in the past? What have you done there?
I've done some small-scale deployments of IoT, so this is my first foray into an actual OT type of implementation. My practices that I've done previous to diving into mousetraps in terms of deploying these into restaurants and understanding where the patterns of mice are to catch the most mice so that the traps are kept clean to catch more mice at these restaurants. I haven't really dabbled into the OT piece, and that's my next step in terms of where I want to go with my career. So what can you tell me in terms of the differences that you have to take into consideration with OT?
That's great. You know, it's funny, a lot of people conflate IoT cybersecurity with OT cybersecurity, and they have very different functions in the world. Otherwise, they wouldn't have like different three-letter acronyms, of course, because that's the most important thing. But operational technology has been around. The first PLC was produced, I think, in 1969 by General Electric. And that was really the biggest difference between this digital idea, or zeros and ones, of automation and what came previous to that, which is steam automation. And while we're not going to go that far back, being in the restaurant industry or having had some experience with it, that steam is still used in a whole lot of operations whenever it comes to like dish cleaning and things like that, temperature of water and all those kinds of sorts of things. So it's funny. There's this bleed through between, what people think, and it's the no-see-ums. They can see this thing every day and not realize that it's actually part of a cybersecurity plan or should be part of a cybersecurity plan. And to that point, you can talk about TV shows that are actually pretty good and fairly close to what the hacking ethos is, and they put Raspberry Pis behind thermostats and things along those lines, as well as and that's considered an OT cyber attack. So you'll see that, even though, some of the stuff, at least on the hacking side, comes at us from the IoT cybersecurity or even from the IT side of the house, OT, because of its soft underbelly, because of the way it's been treated over time, that things have to work and not just be secure. That perspective is very, very different between the two different types of technologies. So we're definitely going to delve into that. And then we're going to talk a little bit about Industry 4.0. So you ready for this one?
Yeah, let's do it.
All right. Why is a 1969 Corvette, considering it was one of the faster cars of its time, slower than a four-door, four-cylinder commuter car nowadays? It makes less horsepower, and it's slower to make that horsepower than your typical four-cylinder car. Why is that?
Is it a weight to power ratio?
Oh, gosh, I wish it was. I wish it was. Actually, cars now tend to be heavier because they're made out of high carbon steel, which actually survives a wreck much easier. So it's bendier and gushier. So it actually tends to be able to stand a wreck, especially a frontal wreck. So we're actually all safer for it now. But cars are actually heavier than they were back in the day. But it's a good guess. It's a very good guess. I get a lot of people that say computers, and for that I have to ask, does a computer get out and push the car? That's not really the case, is it, right? So really when it boils down, there's 1,000 sensors in the motor of that four-cylinder car, measuring, pressure of gas, the amount of oxygen in the cylinder, when it's firing in the spark of it, the temperatures, and all this other kind of stuff. So you're getting if you just leave a car turned on and don't even press a gas pedal, you're getting about a gig of data per hour out of that car, just on the sensor data alone. And what that computer is there is to make real-time decisions on what's happening inside that car to make that car faster and way more efficient than that old Corvette. Now, the old Corvette may be a little bit prettier, Just depends on what kind of commuter car you've purchased that year. Some people's tastes, vary, so I'm not going to make any conjectures there. But the point is, if that's happening inside of a vehicle, and that's just an edge case, no pun intended. Okay, maybe a little bit of a pun. But if that's happening inside vehicles, why wouldn't that happen in manufacturing? So it's coming. Right? We already see the bleed through of this idea called Industry 4.0. So some people say, oh, it's robotics. Some people say it's AI, even though that, for people like you and me, that acronym probably makes us cringe a little bit because we like talking about machine learning, right? But, all those things aside, Industry 4.0 is coming here not because of anything else, but other than the data. So since we have all this new data, and we know that when it comes to IT security, data is the core of what we need to be able to fix. That's what we need to protect. What is the difference about the data in IT cybersecurity as opposed to OT? And to that, I point at differences in an IT cybersecurity pyramid and an OT cybersecurity pyramid. And I've got a graphic I'll show with this. And essentially, what it boils down to is that IT cybersecurity boils down to a 3-letter acronym. And if you're a CISSP, you know what it is already.
No, I do not.
You don't? Okay. CIA, right? Confidentiality, integrity, and availability. And that order is really where the important parts of an IT cybersecurity, I would say, call it the hierarchy of needs, whenever it comes to those sorts of things, right? Yep. So we have confidentiality, integrity, and availability. On the OT side, where confidentiality is being the most important on the IT side, right? On the OT side, what do you think is the most important component of their cybersecurity practice?
I would say reliability, because you would have to have the operations of the actual device working.
So we'll just say reliability and availability are sort of the same thing, right? And you're darn close, right? I can even conflate that and say that the safety portion of it, when it comes to reliability, is part of exactly the thing that you just said, right? So the fact that you said, say reliability, safety can be definitely part of availability and safety. You're dead on, and you're one of the few people to kind of guess that, right? Because most people, you'll not see confidentiality very much in the OT side at all because they don't care. Normally, that's changing a bit, right, with intellectual property loss, but we'll get to that in just a moment, right? So safety is the most important part of that, because safety systems actually make the whole system unreliable, sometimes on purpose, right? It'll take things down. It's supposed to shut things down kindly and make sure something doesn't blow up or people don't die. So safety is the most important part of that. Well, that changes up the equation whenever you're dealing with cybersecurity completely, right? One has a confidentiality as being the kind of the mainstay of it, and you can say if it's a kid's game, it's sort of like keep away, right? So one kid in the middle, I'm trying to keep my data away from you, I'm going to toss it over around you or something else like that. So that's keep away. On the OT side of the house, since it's safety and availability being the most important, and you use the word reliability, I like that one. I would definitely say that's more of a king of the mountain kind of game for the kids, right? And so there's two different ways that we can actually talk about the difference between OT and IT cybersecurity. We can boil it down to a kid's game. I think we all win a little bit because everybody can understand it a little bit better. So since this is your first foray into this sort of thing, you've probably never seen something called the Purdue Model, right? And the Purdue Model is kind of a layered model, very similar to the OSI model. And so a lot of people also, again, get them a little bit mixed up. But Purdue was originally not a cybersecurity model, which everybody tries to kind of fit it. It's sort of a roundish peg in a sort of overly square hole type situation. So it sort of fits, but then it sort of doesn't, right? Because it was about segmentation of zones of availability or zones of responsibility inside the plant. Well, that was really more about safety than it was about cybersecurity at the time, or anything like cybersecurity. So that's part of the problem. So you have this levels, and below all the other levels is the safety zone, and it kind of bleeds through up all the different levels of the Purdue model. Level 0 is basically the electrical model, very electrical portion of the model, very similar to your OSI part, right? Level 1 is essentially what you call the basic controls, and that's really, and the electrical level, the 0 one, is really where your electrical motors, your actuators are, any kind of things that move, like a wind fan or anything. That's the actual physical part of the actual process itself. Level 1 is sort of the electrical layer, and where electrical sort of starts meeting very, very basic control sets. Is the switch off or is the switch on? Or is it off and on and off and on so fast it's making the motor go half speed or sort of, and that's called pulse width modulation, right? That's really at that level 1. So if you look up PWM, there's tons of videos on it of people expounding about what they like to talk about, right? And then level 2 on that whole thing is what you refer to normally is the real-time protocol. And a lot of people call it real-time protocols as opposed to TCP/IP for one very specific reason. Everybody's like, oh, because it's got to be fast. Well, to some degree, it's got to always be on time. So these real-time protocols are about very precise timing for sure. And that's definitely one piece of a real-time protocol. What would you guess the other one was? What's the difference between TCP/IP? What is really the TCP/IP model based on? What's the top of the food chain on the 7-layer OSI model?
Communication?
Well, that's application, right? It's all about the app.
Yes.
And what does an app do? What does an app do? An app talks to humans, right? Machines, when they talk to machines and OT stuff, they only talk to the machines. They really don't talk to the humans. It doesn't talk to humans until you get up to a human-machine interface or engineering workstation. So really automation and this operational technology is really just about machines talking to other machines. Do they care about an application layer then? No. So essentially, it's just you eschew that whole top portion of the OSI model. And that's the other reason why something's called a real-time protocol is because it never there's no application there normally. It's just machines talking to machines. Now, we're not all Neo yet. Although maybe we'll eventually be if we're allowed to have chips in our head. So that's not happening today, at least not to me anyway. Since I can't talk directly to the machine, I need an application to do it. And that's really where this stuff comes in. And one of the big differences of a real-time protocol versus TCP/IP is there's just no intention of an application ever, in that particular since you're not talking to humans. Right. So those are the two things that really make up a real-time protocol. And that's that level 2. And that's really where we expose the soft underbelly of this operational technology cybersecurity, because everything above it can be kind of considered IT. Above level 3 of Purdue and above, you're starting to bleed computers into that sort of thing. And that's where you're getting some of the IT stuff, even though these workstations are behind layers of firewalls and we have an air gap and, it's different completely from our enterprise levels way up here. These are, engineering dedicated computers, that sort of thing. It's still a computer, which means there's still some IT associated with it. And there's no way we're going to get away from that. So you start getting up to level 3 of the Purdue model, you're getting into that TCP/IP talking to humans layer. That's really not as the big a concern as the level 2 and below, which is exactly where I used to work in a company called CyberX, which was purchased by Microsoft, which is now Azure Defender for IoT. That's really where that cybersecurity piece plays in. And so when you're talking about those sorts of level 2 or real-time protocols, you're really talking about something called a distributed control system, or a DCS. Have you ever heard of the term before?
I have not.
So when you usually talked about OT, can I get a raised hand? Did you call it SCADA all the time?
Yes, and that's the thing, right? We yeah.
Well, I did too. When I first went to work for oil and gas companies, I'd come off fresh from being a internet service provider, network engineer, right? And I had come into oil and gas, and they all started laughing at me because I really had no idea what it was. Oh, that's all SCADA stuff. We dealt with that. I know what that is. It's building management systems and battery backup systems and things like that. I did all that stuff. It's got some little corny protocol that goes with it, and it doesn't really matter. Well, what's the fastest way to shut down any data center? Do something to the battery stack, the generators, and or the crack systems for the air conditioning, right? So easiest side channel attack in the world to take down the whole data center, not just part of it, right? So to that point, that's where we're more worried about these sorts of things, because we see more and more side channel attacks coming in. If some people want to call them supply chain attacks. It depends on where you're at. People attacking the thing you do as your core business, whether that be monitoring software for your IP networks, or if it's your air conditioning system for your building management system, if you're a hospital or something like that. So we're seeing more and more of these side channel attacks attacking not just critical infrastructure, but all kinds of things that have to do with our economy and maybe our health and things along those lines. So since we're seeing it bleed down in there, we're really very concerned about these layers that classically haven't been protected, because people are like, oh, nothing happens out of that layer. Well, if you have an engineering workstation, you've hopped around over the network and you finally figured out how to get into that, hop that air gap, because given enough time, anybody can pick something apart, whether it be remoting into this workstation or something else like that, using VPN technology or something because you've stolen someone's credentials. That's what actually happened on the Triton attack to try to get to the safety systems of a plant, right? And so when we're dealing with those distributed control systems, everybody's like, oh, you can't talk to them unless you get to the engineering workstation. Well, that's not true. I only need 3 scripting languages, and that means that it's only in memory. Do I need this? I don't need it written to a disk. I don't need malware to get from outside your entire infrastructure to your OT systems. And the first one is Java, right? Hop on your browser, put a little bitty resident, dropper on there. The second one is Mimikatz, which is basically essentially PowerShell. So that's my second scripting language is PowerShell Empire, right? And the third is Python. And Python's loaded on so many workstations, especially the stuff in the lower layer, because you can load PyModBus, you can load PyDMP3, or any of these libraries allows you to talk these real-time protocol languages directly from a computer. And if you've got that kind of control, you're reaching all the way down into layer 2 and making some real impact there. So, and that impact is actually with something called ladder logic. Have you ever heard that term before, ladder logic?
I have not, no.
Have you heard of something called determinism before, deterministic behavior?
Yes, that's the whole aspect of you're continuing the attack to make sure that you actually get through, and you continuously put forth effort to try to get to the data you're trying to get to.
Yeah, it's a stepped attack, very similar to your MITRE ATT&CK framework. So you've probably heard determinism associated with MITRE ATT&CK, right? Well, it's been in distributed control systems forever, because usually if you're a big fan of Nick at Night, I guess that's probably our age if you're talking about I Love Lucy. There's a very famous I Love Lucy episode with her on a chocolate bonbon line, and she's there with Ethel, and they're wrapping the little bitty candies, and they're doing just fine until somebody changes something, right? You watch it, and it's not the fact that they change the speed of the belt. The number of bonbons coming out is really the thing that kind of messes them up. So they're stuffing it down their shirts and, eating the bonbons and trying to get rid of them any which way they can just so they can catch back up again. Well, very small changes in OT systems, which are deterministic. If this happens, then this thing happens, right? If I speed up the belt, I've got to speed up my wrapper as well, right? And if I don't do that, if I put the number of bonbons on there that's way too many, some of them don't get wrapped, they gum up the works, and, all of a sudden you have this cascading effect. And that's what determinism is, essentially, is once I've done this little bitty thing, I can have this butterfly effect where it increases automatically in a wave, right? And so this deterministic behavior is what creates these sorts of problems. And this all comes from the ladder logic that's usually built into these programmable logic controllers, which take this digital I/O piece. Well, what they really do is they take this real-time protocol where you're just loading stuff in memory registers with this little bitty super thin operating system. I just load something in this memory cell here. That means that this thing's got to blink at this certain speed, right? That's all that programmable logic controller does, regardless of what protocol it talks, right? And then that turns the digital I/O, which turns little bitty switches on and off at electrical level for that on-off digital piece, which then has an effect on motor speeds and all kinds of other stuff like so. That thing that translates all that stuff is a programmable logic controller. That thing depends upon the ladder logic of this architecture. And so if you're not directly seeing what that thing's doing and seeing that determinism has been changed on the network, you can't really see what's going on. And that's really what the big key difference is here. Everybody's like, oh, we've got this behavior analytics for the endpoints and stuff like that. But does it track this idea behind determinism? If the changes happen here, what happens on that cyber physical side? And the cyber physical side is weird. You and I were talking previous to the recording, and we said, hey, have you ever shut your faucet off really, really quickly before? And you said, sure, yes. Right? Yeah. What happens what happens? What do you hear?
You hear the pipes rattle.
Right. Well, turn off really, really quick. All of a sudden, you hear a dong in the ceiling, right? That's because the pipe just goes. It smacks because the compression wave of you stopping that valve very, very quickly and it hits the rafters. Well, that's what you're hearing. Well, you hit the rafter hard enough and your pipes aren't going to last very long. So you probably shouldn't be doing that too many times, right? But if you do it on and off and on and off, you're going to make the thing, and essentially the same sort of cyber physical attack can happen to things naturally, right? If I take that and shut off the valve to a 1,000 gallon oil per minute pipeline that's about as big around as my house is large, right? And I do the same thing to it, metal doesn't really do very well in that sort of thing, so things can tend to blow up. So that's part of the problem. So understanding that that's the cyber physical aspect means you have to deploy at very, very low layers of this architecture to be able to see that sort of stuff. And that is actually one of our biggest challenges in OT cybersecurity. Are we seeing the things that actually matter in the ecosystem? So knowing that, you have to have a couple different questions about maybe attacks or where to deploy or something else like that. If you have a question, ask away.
So my biggest question right now is understanding from the IT perspective and the information technology or information of things, you're securing the information that's being passed through. In OT, you're doing operational things and you're securing the operations of that aspect. And we're not worrying about the application layer, as you said. We're worrying about the device itself and it working reliably. How are we managing that device to ensure that, somebody isn't just going on and turning on and off a switch, and understanding that it is actually operating properly or based on the mandate of what's required of it? You made mention of that, the tank of oil that is pushing out at a certain PSI that's lubricating machinery. How are we ensuring that, if we're not looking at it from the perspective of the application layer, how are we getting into, in essence, the bias of these devices to ensure that it's actually operating as required? And are there any outside factors, like you mentioned earlier, power? If I can't attack that oil pressure jug, can I just cut the power? And what do I have to know in that respect in terms of the environment that these devices actually sit in?
Yeah, those are great questions. So there's a couple things. I'm going to take it and split it up a bit, right? So yep. One of the things that we mentioned already was the deterministic behavior of something. So if you have your little oil can on the side of your robot that has to feed the robot, oil at a certain speed, or maybe it's a wind farm, right? That oiling can then feeds the motor so it can keep spinning and producing electricity for everybody, right? So regardless of what that is, can I maybe go cut the power to it? Well, that goes back to the deterministic nature of these things. If I'm cutting my power, I've got to send a signal to some part of that framework, which would be the programmable logic controller for that thing, right? If I'm going to go reprogram that on a day, inside a day, or send a stop command to it, that's going to be very different from what usually happens on an operational level anyway. So I have to have this idea of a baseline of what came before it and what things happen on this network. So everybody talks about baselining when it comes to AI and ML type of cybersecurity. And that's one of the reasons why I started doing OT to begin with, is because I love dealing with ML and doing stuff in AI research. I absolutely love that stuff. But I already recognize that application levels cybersecurity, the IT side of the house, is so chaotic and non-deterministic, right? Application based essentially, that baselining doesn't always work that well. As a matter of fact, it can be quite noisy. When you do that in the OT environments, it is a very, very different aspect and takes a different perspective. So I know I don't ever see S7 stop commands in the middle of the day to a pump or a valve, right? So me sending a stop command to it in the middle of the day during production would definitely raise a few alarms. So understanding that baseline for that ecosystem or that network helps me understand how to protect it, right? The other thing, too, is it's one thing to be anomaly detection from a baseline, right? It's quite a different thing to already be pre-trained on what current attack patterns look like, right? And everybody calls these, if you're going to use MITRE ATT&CK framework, TTPs, tactics, techniques, and what is the third one? It is procedures. Thank you. So sorry about that, right? So understanding an attack from to TTP angle is very different from understanding it from like an IPS or AV signature type situation, right? I am understanding my portion of the attack, which looks very similar to these sets of attacks over here. So if I can actually start training that machine model with something that has come before it, I'll shore up that machine model with, hey, this looks a little bit like this attack on the tactics, techniques, and procedures, not just the actual signature itself. And so I'm not playing signature whack-a-mole afterwards. I'm actually bubbling up stuff and then being able to filter out false positives a little bit better. I stack that with something that's been pre-trained to know how a specific process control system works, whether it be on Modbus or DNP3 or Ethernet IP. And I know this ecosystem because I've pre-trained it with what a normal system already looks like. It comes pre-trained. So as soon as you shove the thing in, I don't need a month of baseline learning to give you some insights. I know immediately, hey, that thing's, authentication's messed up. That thing over there keeps rebooting and it shouldn't be. That thing keeps asking for an IP address. That's probably bad. This thing's over here is spraying a lot of traffic. That's probably not good either, because most of that traffic is usually, a couple of kilobits per day, not even megabits, right? Because we're not dealing with applications. Again, we're not transiting large amounts of packets. Well, here's where bringing the data up out of just the sensor level, that layer 2, up into a greater set of analytics would really help you, right? Because you have to be able to correlate what one sensor is seeing to what another sensor is seeing over here, and then not overwhelm with too much signal coming outbound. So this resultant set has to be very, very smart and only give maybe 50 to 100 signals per month. But that data, so if you cut that and you start seeing a lot of signal coming out of this side, you can automatically know that there was a change that was made in the operational side that could affect the entirety of everything and start alerting to that sort of thing. So there is a lot that you can do as an overall architecture placement of that sensing mechanism to features that may not be part of that particular system. So building management systems are usually handled by third-party companies. So putting a sensor on that network, even though it's the third-party network, is extremely efficacious for you, right? Putting on your own to manage your own there is also very, very important. And if you can, dealing with your power from the outside and knowing where that's coming from and putting the sensors in that area as well. So what you're getting here is an information framework that would be able to feed you on side channel attacks right there and know what kind of impact it's going to make on your business. So good question.
So it's capturing the information from the environmentals, not just from the equipment itself, understanding the scenario that's at play, and then when something fails or when it detects that there is something that would affect what the operations of the plant, in essence, it would then make an alert or make notification that this is occurring.
Well, that's the reason why we have the IoT hub bleed together, not just what we have from the CyberX side of the house and the sensor, right? But also from greenfield sensors that you would deploy, also from other brownfield technologies that you can overlay like Azure Sphere, so you can know these changes that are happening on the operational side. So there's just this entire ecosystem from greenfield to brownfield, which is essentially already deployed stuff that you can actually pull that sensor data in, make some sense of it using a few algorithms, and give you basically the operational impact of any given change on your ecosystem. So it's a good question.
Now understanding the logic in terms of the protection piece, what is Defender's role in all of this?
So Azure Defender for IoT, the role that it actually plays is sort of so lots of people like to call it an IDS or IPS, which is an intrusion prevention system or an intrusion detection system. And there are bits of that in the product itself, but it's really falls into this area called an NBAD, which is network behavioral and analytics detection, right? And so what is the attempt of it? Well, it's the attempt to take the workbooks that you have in the core, maybe that usually associated with your SIM, and push them down to the severe edge. Remember that computer in that car that I talked about before, that sensor data that you were getting there? It was able to make the real-time decisions out at the edge, actually inside the car as it was getting real-time data. You can think of that sensor as the ECU in your car. It's making real-time decisions right there. Now, does that mean that the car might call back home one day and get service and know when to get serviced and things like that, and tell the computer in your car that, hey, you can make these little adjustments until you're able to get to the dealership or to the car service center? Absolutely 100%. That's that day's coming both on the car side, and it's pretty much already here on the manufacturing side if you use Azure Defender for IoT. So there's definitely those pieces that if you deploy Azure Defender, you can start making intelligent decisions all the way out at your edge, really help out your operations, not even your cybersecurity, but the operations of your plants, whether you're in manufacturing or your power production, that sort of thing. You can start getting that kind of resultant set of information way, way down at the edge. So that's part and parcel to it.
And what's IT's role at the helm of this? You make mention in terms of the security piece and even the operations piece. What would be the IT professionals then responsibility, or are they reporting back to the plant in regards to where the deficiencies lie or the possible security vectors are? What are the reporting mechanisms that are available? How does IT relay what's being captured back to the organization so that they can be part of the decisions of how the organization will move forward to address threats or optimization?
So we're going to cover that in a little bit of a different talk coming up here in just a minute on a separate talk. But let's take it from the top and give you the 30,000 foot view, and then we'll cover it a little bit deeper in the different discussion. So the sensor is split brained. It is on the operations side where you have operational errors, and it has security for security errors, right? So the operations people aren't going to care on a day-to-day basis. I'm sorry for all you IT cybersecurity people. They just don't care because their answer to quite a few things is turn it off and turn it back on again. We are probably not going to change that in our lifetimes. So, but the fight we can fight is giving those same people a new visibility of that part of the organization where they may not see those operational errors. You're basically giving them a monitor for the stuff that the third-party companies they work with, they won't give them that visibility. So you're giving them almost a deck of exactly what they do on a daily basis. You can make that visible inside the plant for them that they can go and take a look at when everything else fails. We had a very expensive glass manufacturer come to us and say, hey, your system has been in here for about a month and our plant's been down for a day and a half now. What did you guys do to make a change? Because none of us made a change, right? And so they'd done a plant turnaround that weekend. They'd made some changes in the logics of some of their, they upgraded the firmware and upgraded the logic of some of their PLCs. And, it was working fine during the weekend when they did change management acceptance testing. They got outside their change management window. They come back in Monday, all of a sudden everything starts shutting down automatically. So they're at that stage of troubleshooting, which is the pointing of the fingers, right? We've all been there at that stage of troubleshooting before. And they called us up and asked us what was going on. We said, well, this thing is 100% passive. It does nothing on your network. It's all passive analytics. So all we're doing is taking a copy of your traffic and making some really cool decisions on it and telling you what's going on. So have you gone to go take a look at the console? Because there's literally nothing we can do to your infrastructure to do the things that you described. And they said, no, they hadn't. So we go, remote in and we took a look at the screen with them. And then within about 2 or 3 minutes, we find out the problem. What had happened was that a laptop, the one that did the firmware updates, had gone and updated the firmware. And then it said successful, update successful. Well, it hadn't also sent the new ladder logic down to the PLCs as well, right? It came in Monday morning. I guess it failed or something on the network. It came back in Monday morning, reattempted the update of the ladder logic at that point in time outside the change management window. When it did and it was successful, it shut everything down. Well, they didn't see the change. And they hadn't expected the change because, they had already thought it was successful because, what software or application usually has problems. So that's what happened. We saw it happen. We were able to cut and paste back in the changes that were made. And then within 15 minutes, they were back up and operational again. Those are the sorts of things you can help those operations people and the plants fix that particular set of problems. So if you're giving them value while you're there to also do the cybersecurity stuff, which they can't really care about too much until they shut the plant down for ransomware for the entire week or something like that, and everything has to go get reimaged, which happens still, right? So they do care about that part, but not until it usually happens, right? Because they have a job to do, and we have to all recognize that. That's really where that sort of thing comes into it. Understanding, how they do work and how they get paid helps us do our own work and help them stay up. So, good question. So in
regards to first steps, right? We've gone through a bunch of scenarios. We've gone through the definitions of OT and IT, and environmentals being protected, not just the machinery itself, and understanding what could occur. First steps for an organization that now wants to put forth a security effort. Where do they start?
That's great. So they start off with visibility. That is the one thing that we were built to do first, because a lot of these technologies have been black boxed in the past because you hire a third-party manufacturer to come in and put it in for you, because those process control engineers and automation engineers are very rare, usually very expensive. So they're usually a third-party company that comes in, maybe even the manufacturer itself that brings their consultancy services in to do the work, right? So a lot of the technology is a black box, and then once they hand it off, the keys off to you, you're just supposed to run it and then call them if there's any problems, right? So that's the reason why most people don't work on their cars anymore, is because it's so complicated to work on a car. I just want the keys because I got to go drive that car to work, right? You're not going to sit there every day and delve into the car to see how it's working that day, right? So the same can be said for your manufacturing plants. The analogy just kind of holds up across all of it. So knowing that these are black box things and having something new that attaches to your car or your manufacturing plant that then can give you a result instead of changes that are being made within it helps you maybe make some decisions that prevent some outages in the future, right? See what you can't see before. So we always start with visibility, the behavior of that thing, how it gets mapped out, what assets you own, and everything else. And then you can start making some really intelligent decisions after you know something behaves, what you have, what it costs, and what the vulnerabilities of those things are. Once you understand that sort of visibility, everybody can start making some intelligent decisions given the right kind of data. And that's really always the first step.
Thanks, James. This has been awesome. It's been so much information thrown at me here. Been taking copious notes. I'm wondering, in regards to Defender, where do I start grabbing information in regards to that specifically for IoT?
You know, this is really something, having come over to Microsoft, I asked for forever when I was with the previous company, and now it's here, and I'm dumbfounded by it. Anybody with a credit card and a browser can go to the Azure portal today. When you go there, you can actually get Azure Defender for IoT as an app, which is very different for the OT world, right? I'm pretty sure nobody else does this. You can download the sensor, even have it to where you can play PCAPs offline. You don't even have to connect it to your network yet if you have to do some acceptance testing or talk to your talk to your service providers or whatever for your manufacturing plants or for electrical plants, or what have you, whatever you're going to be connecting it to. You can play the PCAPs that you get from those particular networks at it and get some very real information out of it today with some very decent risk analysis just from a packet capture. And that's kind of the power of the tool, that it can see so much within deep packet inspection. The longer you get it, obviously, the bigger the PCAP, or the longer the PCAP, the better result instead of information you get out of it, of course. But that's really where you start. So today you can go to portal.azure.com. Feed in your credit card to get a subscription. Put the sensor either in a VM, or you can even order a physical appliance if you'd like, and then even start dropping PCAPs before you even deploy it on the network. Once you've done that, you can actually plug it into a tap or span port or mirror into your network where you've got the important stuff where you've decided that you want to plug it in at to get better visibility. And then you can actually go from there on monitoring and real-time discovery of things that are going on. Once that happens, you can start tying it into the enforcement portions of your network you probably already invested in. Your next-generation firewalls, your NAC systems, your content filtering, I could keep going on, your zero-trust networking architectures. It can be plugged into all of that to give you that OT muscle and IoT muscle that you may be missing now.
James, this has been awesome. Thank you very much for your time. And if you want to learn more, navigate to portal.azure.com, bring up Defender, and not only will the service be there, but the full documentation made available, specifically covering operations in IoT.
Yes, sir. Thanks so much. Appreciate it.